Hello guys, welcome to my channel. Today we will discuss about like how to create a stack using a single linked list. So before we start, first of all, we should know what is a stack. So stack is a linear data structure which follows a particular order in which the operations are performed. The order may be LIFO, last in first out, or FILO, the first in last out. So here if you see, I have few numbers like 11, 22, 33, 44, 55, 66, and 77. So whenever I have to push something in the stack, so it will go in the below part. So 11 I post, then I post 22, then 33, then 44. And whenever I have to pop something from it, so it will be popped from the top. Like 77, if you see here, it entered at the last. And whenever I have to pop this thing, this is the first thing which will go out. So 77 will go out first. Okay. So this is the principle behind how a stack worked. So whatever goes in, it will come in as a last in parameter, and whatever goes last will come as a first element. Okay. Okay, next we will talk about what is single linked list. So as you can know, like if these are the numbers 11, 12, 33, 44 like that, if we have to present it as a linked list, then first element will be our head element, and there in the this is the address portion. Here actually the next node's address will be present. So 22 is a node which address is present in 11's next portion. Like that way it is growing. So then I am adding 33, 44, 55, 66, 77. And if after 77 there is no value present, then 77's address part, it will come as null. So this is where we will present something as a single linked list. Okay. Now we have to discuss how we can convert a stack as a linked list. So here I take one stack and I will present linked list, and I will show you the operation side by side. First operation we will talk about is push operation. See here 11 I pushed in the stack. So how you represent the same thing in linked list? So same thing you have to represent in linked list like this way. You have to create a first node and you have to mark it as head node. Then I am pushing 22 in the stack. So how you will present this thing in linked list? You have to add another node next to 22. Now you are adding 33. Then you have to add 33 here also. So what you are seeing here is when actually I am adding something in the stack, means I am pushing something in the stack like 44. What actually I am doing, I am traversing from the head to the last node, then I am identifying what is the last node, and next to that node I am adding this 44. That means this push operation, the time complexity is on, means I am traversing the whole linked list, then I am finding the position, and then I am pushing something here. So if I am taking the normal approach, then it is clear from here, like if I am pushing something in the stack and I am representing the same thing in linked list, it is taking O enough time, because from the head we are traversing to the whole linked list. I am finding the position, then I am adding it to that. Like that way 55 also I added, and it is going like this. Now we will discuss about the pop operation. Okay, so same thing you can see here, the stack is present here and the linked list, and the first node is pointing as head here. So now we will do a pop operation, means we will remove one value from this stack. So I am removing 55. So what will happen? So you have to traverse to the whole linked list, and we have to find out what is the last value, and you have to remove this one. So this is a pop operation which I am doing in stack and similar to linked list. So in linked list you have to present the same way. Then you have to traverse to the whole linked list, and you have to identify the last element, and you have to pop that element or remove that element. Okay, like 44 is I am removing from the stack, and same way it will be removed from the linked list also. So you can see here for the pop operation also it is taking O(n) of time, means we have to traverse the whole linked list, then you have to find out what is the last element, and we have to remove that one. Okay, so the pop operation is also taking On if we are going through a normal approach. So in the next video we will see how to improve this. So that is the motto about this video, like how to improve this one. So how we can perform the same operation of push and pop, not in O time, but less than that. Okay, now we will discuss about the best approach, like how to modify the time complexity from ON to O1, both for push operation and pop operation. So if we do something like this, then what will happen? Like I am pushing something in the stack, like 11. Then we are creating one node and assigning it as head because it is the first element in the linked list. Then whenever I am pushing something again, so what I was doing before, in the 11th next position, I was placing this 22 as a node. So if I do something different now, like if we place this 22 before 11 and then we will remove this as head and then we will assign 22 as the new head, then what will happen? So I will insert one more thing, then I will explain how it is benefit. So I am pushing again 33, then in the same way 33 I will insert in front of 22 and then I will delete 22 as the head and I will create 33 as our new head. So what benefit we are getting in this approach? Suppose now we know like this 33 is our new head. So next time if I have to insert something like 44 or something, then what we can do is we can do something like this, like before 33 means whatever the new element will come, that's next position we can assign it to 33 and then I can assign this new 44 is our new head. So that time like in a first shot only we can insert something, means this time it is taking O1 of time. So similar way, if I have to pop some element, suppose I have to pop 33 because this is the topmost element. So how we can do this thing is, so we have to just delete 33 and then we have to assign 22 as our new head. Okay. So 33 we have to delete, then we have to assign this 22 as our new head. That way what will happen? The pop is also in the same sort. So the difference you must be understood, like previously what we were doing is we were inserting the element after the head's next node. So now we are moving the head itself. So that way we can decrease the time complexity from ON to O1. Okay. Now coming to the coding part. So what will happen for push operation? So if we are writing a function called push operation and if I am passing the head and the new value which I am going to push. So first I will check if the head is null or not. If the head is null means nothing is there in the stack. So what I can do is that time I can create a new node and assigning that as our new head. If head is already created, means head value is already present, then what I can do is I just create the new node with the new value and then so that node's next value I can assign as head and then that head will become our new node. So the latest node will be our new head. Or if you talk about like stack related term, that is actually a top. Okay. So coming to pop part. So pop part what we will do? So again we will pass the top part. So if we see the top is already null, that means nothing to pop from there. So we can simply print a message called stack is empty. There is nothing to pop. If it is not empty, if it is not empty, then what we can do is here also two things we can check. One is it the last element present or already some more than one element is present or not. So I am checking like top dot next not equal to null, that means more than one value is present there. That time what I am doing, so I am in the new top, the new top will be the top's next position. So whatever is top now, the top's next will be our new top, then top's next I am making it as null and our top will be the become the new top. Okay, and I am printing like removing top dot val because from top portion only we are removing the value. If in the same else part, if you see here, like only the single value is present, only the last value is present in the stack, that time I'm just simply removing it and I am mentioning like top equal to null. So next time when someone again want to pop it, then he can get like this top equal to null, that means the stack is empty. So hope you like this video. So the code, actually the complete code, I will mention in the description area. The GitHub link I will share with you. Okay. Thank you everyone.